Hi viewers, this is Panikumar, Senior Lecturer in Chemistry. In this video, we are going to learn about different kinds of chemical changes and balancing chemical reactions and how to balance those chemical reactions. That and all we are going to learn in this video. What does it mean by a chemical change? Generally, all the changes that takes place in our surroundings are classified into two different types. We are having two different types of changes in our surroundings. What are they means? Physical changes and chemical changes. How many kinds of changes we are having in our surroundings? Two different types of changes are there in our surroundings. What are they means? The first one is the physical change and second one is the chemical change. These are the two different types of changes we are having in our surroundings. What are the examples for these two different types of the changes? If I have taken physical change, the generalized example, if ice is taken out of the deep fridge and if it is kept in the normal atmosphere, then what happens? Ice melts and that will be converted into water. So the changes in which there is only change in the physical state of a substance. Simply, there is a change in the physical state of a substance, or if one allotropic form is converted into another allotropic form, that is called as a physical change simply. Here, in physical change, what happens means no new compound is formed. In physical change, there is no new compound is formed. The change in which a new compound is formed with the change in composition. Here what happens? A new compound is formed over here and there is change in the composition of the product from the reactant. So if the compound chemical composition is changed, then such a kind of change is called as the, what we can say, chemical change. Example for this chemical change, burning coal in air. Burning coal in air. So we know that coal means nothing but carbon. Coal means nothing but carbon. If carbon is burned in air, what happens? That will undergoes combustion process and forms carbon dioxide. Complete burning of a substance in the presence of air is simply called as combustion. So when coal is burnt, what happens? That will form carbon dioxide. That forms carbon dioxide. So here what happens? If coal is burnt to give carbon dioxide, instead of writing in the words, if I use symbols and formulae, that is called as a chemical equation, and the chemical change may also be called as a chemical reaction also. So instead of coal, if I use carbon, right, and it reacts with the oxygen present in the air, C plus O2 gives rise to CO2. This is called as a chemical reaction. In the same way, hydrogen reacts with the oxygen to form water molecule, if I say H2O. This is also a chemical equation. If you observe these two equations, what happens? The number of atoms participating in the chemical reaction is equal to the number of atoms that are present in the product. If both are equal, such a kind of chemical equation is called as a balanced chemical equation. That is called a balanced chemical equation. If the number of atoms in the reactants are not equal to the number of atoms in the products, that is called as an unbalanced chemical equation. Here you can see one carbon is in reactant, the same one carbon is produced in the product. Two oxygens in the reactant, two oxygens are produced in the product. So it is a balanced equation. Next, here two hydrogen atoms are in the reactant, two are produced back in the products. Next, two oxygen atoms are in the reactant, only one oxygen atom is produced in the product. Okay, So what happens? This is called as an unbalanced chemical equation. That is called as an unbalanced chemical equation. So here, if unbalanced chemical equations are given, how to balance those equations? So that is called as simply balancing chemical equations. Here, this balancing of chemical equation, is majorly done in two different methods. Two different methods are used for balancing chemical equations. What are they means? The first one is the oxidation number method. The first method used for balancing unbalanced chemical equations is oxidation number method, and the second one is the ion electron method. Oxidation number method and the ion electron method. Two different methods are used over here for balancing an unbalanced chemical equation. Apart from this, we are having trial and error method also, but that is not widely used nowadays, and there are no systematic rules and regulations for balancing the unbalanced chemical equation in the trial and error method. So today we are going to discuss about these two methods in this video. The first one is the oxidation number method. How to balance the equations in oxidation number method. How to balance the equations in oxidation number method. So what you have to do? What are the different processes? What is the procedure you have to follow for balancing an unbalanced chemical equation? The first one is take the skeletal unbalanced equation. Take a skeletal unbalanced equation. Skeletal unbalanced equation you have to take. Okay. And after taking an unbalanced equation, second step, you have to find the oxidation number of all elements in the given equation. Okay, so you have to find the oxidation number of all elements in the given equation. And in the third step, identify. What you have to do? Identify the atoms. Okay, the atoms whose oxidation numbers are changed. Whose oxidation numbers are changed. You have to identify the elements whose oxidation numbers are changed and underline them. Okay, and you just underline them. And after that, segregate the equation. Okay, or else what you have to do? Underline elements. Write two different equations. Write two different equations using only the elements, which undergoes change in oxidation number, Okay, you have to write two different equations using the elements whose oxidation numbers are changed. And next, find the change in oxidation number. Okay, what you have to do? Find the change in oxidation number. Find change in oxidation number. In one equation, oxidation number is increased, and in another equation, oxidation number is decreased. Next, balance the change in oxidation number. That means balance increase in oxidation number and decrease in oxidation number. Okay, so simply you have to cross multiply those numerical values. You have to cross multiply the numerical values. They are called as coefficients. And rewrite the equation. Using coefficients to get a balanced equation. This is the process of balancing the unbalanced equation using oxidation number method. What you have to do? You have to take the skeletal balanced equation, and next you have to find the oxidation number of all the elements involved in that equation and identify the elements whose oxidation numbers are changed, and next you have to write the equation using only the elements whose oxidation numbers are increased, and then what you have to do, and then using the coefficients you just rewrite the equation. Just have a look at that process once. I am telling you, take the unbalanced equation, find the oxidation number of all the elements. Next, identify the atoms whose oxidation numbers are changed. Next, write the equation using the elements with the change in oxidation number. Next, find the increase in oxidation number and decrease in oxidation number. Next, balance the increase in oxidation number with the decrease in oxidation number. Simply cross multiply those numerical values. Those values used for the cross multiplication are called coefficients, and rewrite the equation using the coefficients to get the balanced equation. So the entire process is displayed on the board. Just have a look at them once. Now let us see how to balance these unbalanced chemical equations using oxidation number method. So on the screen you are having an unbalanced chemical equation. What is that? The first one is MnO2 reacts with HCl to form MnCl2 and H2. Merely by looking at the equation you can say all the reactants that are involved in this process, what are they? Manganese, oxygen, hydrogen and chlorine. See, here you are having one manganese, here you are having one manganese. It is balanced. Here you are having two oxygens but there is no oxygen in the product. Here you are having one hydrogen, there is no hydrogen in the product. And here you are having one chlorine, there is totally 4 chlorines in the product. So this is an unbalanced chemical equation. This unbalanced chemical equation should be balanced in the oxidation number method. This is the skeletal equation. Next, what I told in the second step, you have to find the oxidation number of every element involved in this equation. This manganese, already you know, X, oxygen is having oxidation number -2. X minus 4 is equal to 0, X is equal to +4 here. And oxygen oxidation number is -2. Oxygen oxidation number is -2. Oxygen oxidation number is -2. And next, hydrogen. Hydrogen is having a +1 oxidation state. Chlorine is having -1 oxidation state. Here, manganese oxidation state is +2. Chlorine is -1. Here chlorine oxidation number is 0. So you just identify whose third step. Identify the elements whose oxidation numbers are changed and underline them. So here you can say manganese oxidation number is reduced from +4 to +2. That means it is a reduction process. It is a reduction process. And chlorine oxidation number is increased from -1 to 0. This is a oxidation process. So we just find the oxidation numbers of the elements and we just identified whose oxidation numbers are changed, and I told you to underline them. So these are the elements whose oxidation numbers are changed. And write two different oxidation numbers using the elements whose oxidation numbers are changed. Forget about the bonded atoms to those elements. You just take those elements, including with the oxidation number, you just write two different equations. That means here the third step, Mn+4 is changed to Mn+2. This is a 1/2 reaction. This is called as a reduction half reaction. Okay, this is the reduction part. And next, Cl minus is changed to Cl2. Cl minus is changed to Cl2. So after writing that, if the number of atoms involved in the skeletal equation, this equation, are not equal, first balance them. Here how many manganese atoms are here? 1. Here how many manganese atoms are here? 1. So both are equal. So rewrite the equation as it is. Mn+4 gives rise to Mn+2. Mn+4 gives rise to Mn+2. all the atoms are balanced here. What happened? All the atoms are balanced here. Right. Next, if you come to this equation, here you are having only one chlorine, here you are having two chlorines. So 2Cl minus gives rise to Cl2. Right. Now what happens? All the atoms are balanced here. Here also all the atoms are balanced. This is the third step you have to do. And next step, what you have to do? You have to find the change in oxidation number. What you have to find? You have to find the change in oxidation number. The formula for change in oxidation number, oxidation number is equal to oxidation number in products minus oxidation number in reactants. Okay, oxidation number in products minus oxidation number in reactants. Now what is the change in oxidation number here? Oxidation number in product is 2 minus 4. That means the magnitude of the oxidation number is reduced by 2 units over here. And next, increase in oxidation number in this reaction. The change in oxidation number is 0 minus 2. So for each chlorine minus 1, 2 chlorines are there. So minus 2. Is it minus of minus 2? Right? Here you are having minus 2. Minus of minus 2 means plus 2. So minus 2 is the increase in oxidation number, and plus 2 is the minus 2 is the decrease in oxidation number. And next, what is the next one? Plus 2 is the increase in oxidation number. So here both are balanced. So if you want to get both the change in oxidation numbers are equal, so the coefficient here will become 1 over here, right? The coefficient will become 1 over here. Using these coefficients, you have to write the equation over here. Using these coefficients, you have to write the reaction. Now, what is the coefficient for manganese? 1. That means you just write 1 in front of manganese wherever you find in the given equation. So here, what I can do? I can write MnO2 as the coefficient of manganese is obtained as 1 over there. Plus, next, wherever you find Cl minus, 1 into 2, here the chlorine atoms are not balanced. So already we have taken one coefficient, here one coefficient. 1 into 2, what happens? You will get 2HCl. What you will get? 2HCl. So 2HCl gives rise to, wherever you find manganese, what you have to do? You have to take 1 over there, MnCl2, plus wherever you find the Cl2, what happens? 1 is the coefficient, here also 1. So you can write Cl2. So this is one of the reaction we got. But what about the hydrogens? What about the hydrogens? Here 2 hydrogens are there. So you have to write H2O over there. You have to write H2O over there. Even if you did this one, what happened? The reaction is not balanced. What happened? Here you are having one oxygen atom deficiency and 2 chlorine atoms more. One oxygen atom deficiency and 2 chlorine atoms are more. So you just do one thing, add 2 more HCl molecules, okay, to balance the oxygen atom, because 2 hydrogens will join with the 1 oxygen atom. Here 1 oxygen atom is not balanced, so you need to add 2 more HCl. So we add 2 more HCl's over here. MnO2 plus 4 HCl gives rise to MnCl2 plus Cl2 plus here total 4 hydrogens. So you will get 2 water molecules over there. So this will be the balanced equation. This will be the balanced equation. You check 1 manganese in the reactant, 1 manganese in the product, 2 oxygens in the reactant, 2 oxygens in the product, 4 hydrogens in the reactant, 4 hydrogens in the product, 4 chlorines in the reactant and 4 chlorines in the product. This is the way of balancing the equations in oxidation number method, right? Let us take one more example for that. Let us take one more example for balancing these reactions using oxidation number method. Now let us see another example for balancing the unbalanced equation in oxidation number method. That is nothing but very simple equation. H2SO4 reacts with hydrogen iodide Hi to form H2S plus I2 plus H2O. This is an equation given for us. H2SO4 reacts with Hi and forms H2S, I2 and water. So this is an unbalanced chemical equation because you can see the number of hydrogens in the reactants are 3, but there in product you got 4 hydrogens. The number of iodines here are 1, but you are having 2 iodines in the product. Oxygen here 4, there only 1. So that is an unbalanced equation. So take the skeletal equation, that is the skeletal equation over there, and find the oxidation number of every element in this equation. We know that hydrogen is having +1 oxidation state, oxygen is having -2 oxidation state. As 2 hydrogens are here, 2, we don't know the oxidation number of sulfur, so +X. Oxygen 4 are there, so -8. 4 plus X minus 8 is equal to 0. What is that? 4 plus X minus 8 is equal to 0. Now, 2 plus X minus 8 is equal to 0. And X minus 6 is equal to 0, X is equal to +6. So the oxidation number of sulfur in the H2SO4 is +6. And hydrogen as usual +1, and X +1 is equal to 0, X is equal to -1. And in the product, 2 plus X is equal to 0, X is equal to -2. And iodine is having 0. I told water is a spectator molecule that is formed due to the reaction. So now identify the elements whose oxidation numbers are changed and underline them. Here the sulfur oxidation number is changed from +1 to +6 to -2. Iodine oxidation number is changed from -1 to 0. So write down. I minus gives rise to I2. This is one change in oxidation number. Next, S plus 6 oxidation number is changed to S minus 2 oxidation number. Here -1 to 0, that means increase in oxidation number. So it is the oxidation process. Here +6 to -2, decrease in oxidation number. So it is a reduction process. Now the number of atoms in these skeletal equation are unbalanced. So first balance them. So how to balance? I can write 2i minus gives rise to I2. So the number of atoms are balanced here. Here already the balanced atoms are there. +6 gives rise to S minus 2. So the atoms are balanced over here. And next what we have to do? We have to find the change in oxidation number. I told you a formula. Change in oxidation number is equal to oxidation number in product minus oxidation number in reactant. Here you are having 0 oxidation number for iodine. So 0 minus of -2. That means the change in oxidation number is +2 over here. This is increase in oxidation number. Here what happened? -2 minus of +6. That means here what happened? -8, right? Minus of plus means -8. So the increase in oxidation number is +2, decrease in oxidation number is -8. But in any chemical reaction, the increased oxidation number should be equal to the decrease in oxidation number. To get the number of electrons transferred equal, multiply the change in oxidation number with the suitable number to get the equal value. So if I multiply this +2 with 4, I will get plus 8 over here. If I multiply this with 1, I will get minus 8. So the increase in oxidation number is equal to decrease the oxidation number. So the number which is used to get the equalizing the number of electrons transferred, that means for equalizing the increase in oxidation number with the decrease in oxidation number is called coefficient. So in this reaction the coefficients are 4 and 1. So here already we are having another coefficient for iodine, that is 2. So to get the balanced equation, using these coefficients you just write the equation again. So first let us take H2SO4. And what is the coefficient in front of H2SO4? Here 4 and HI, let me take HIO first, HI. So wherever you are having I minus, the coefficient is 4 into 2, 8. The coefficient in front of HI you have to write is 8 HI plus sulfur. You just see the coefficient is 1 in both the cases. So you just write 1 in front of H2SO4. 8 HI plus H2SO4 gives rise to. Wherever you are having I2, the coefficient is 4 only. Here only one coefficient. So wherever you are having I2, write 4 in front of I2. So you just write 4I2 plus next H2S. Wherever you are having H2S, S minus 2, the coefficient is only 1 over there. So write 1 H2S. You need not to write 1 over there plus. Find the number of oxygen atoms that differs. Here you are having 4 oxygen atom, but no oxygen atom is reflected in the product. I told you the number of oxygen atoms that are deficient are reflected in the form of water in the product. As you are having 4 oxygen atoms deficiency, you just write 4 water molecules in the product. Now this will be the balanced equation. You can check here how many hydrogens in the reactant. 8 here and 2 here. That means altogether 10 hydrogens. So here 2 in H2S, 4 2s 8 in H2O. So 10 hydrogens. So hydrogens in reactant 10 and in product also 10 hydrogens. Now calculate the iodines. Here 8 in iodines, 8 in reactant and in product 4 2s 8. So iodines are balanced. How many sulfurs here? 1. And in the product also 1. So the sulfur atom is also balanced. How many oxygens are here? 4. And in product also you are having 4 oxygen atoms. Now charge. The net charge of the reactant molecules in the reactants is 0. Here also all the molecules are having 0 charge. So charge is also balanced. So this is the process of balancing an unbalanced chemical equation. Again I will tell you the process, you just remind. Simple. First take the skeletal equation, find the oxidation numbers for each and every element and identify the elements whose oxidation number is changed. Segregate them and write in the form of 2 different equations with increase in oxidation number and a decrease in oxidation number. And then if the number of atoms in the skeletal equations are unbalanced, first balance them and then find the change in oxidation number. Change in oxidation number means oxidation number in product minus oxidation number in reactant, and equalize the increase in oxidation number with the decrease in oxidation number. The numbers used for equalizing the charge are called as coefficients. If you write the equation using these coefficients, you will get the balanced equation. If any oxygen atoms are deficient, balance those oxygen atoms by using water molecule. Okay, if 1 oxygen is deficient, write 1 water in the product. If 2 are deficient, write 2 water molecules in the product. Then you will get the balanced equation. I hope you enjoyed this class. Thank you.